Hey guys, welcome to Biddy's Math Binder. Make sure to take out pencil and paper so that you can follow along with me. Today we are going to learn all about the different ways to factor. The first type of factoring that we're going to focus on is GCF, which is the greatest common factor. Let's start with this problem here. I need to find a greatest common factor within both of those terms. I see that I can take a 3 out of 3 and out of 6, and I can take an x out of the x squared and out of the x. So that's my greatest common factor. To figure out what I'm left with after I pull that greatest common factor out, I basically just divide. So I can take that first term, 3x squared, and divide it by the GCF 3x, and I will get x. That's what I'm left with on my first term. I can do that same process, 6x divided by the GCF, and get 2 for my final answer of 3x times x plus 2. Let's take a look at another problem. Same concept. I need to look and figure out what the GCF is from both terms. I notice it's 8x squared. I'm going to take the first term and divide it by my GCF. That leaves me with 2y squared. I'll do the same thing with my second term and divide it by the GCF, which just leaves me with 1. There is my final answer. Let's look at one more problem where GCF is our main focus. I want to take a GCF out of all 3 terms now. So I can take a 5 out of the 15, 10, and 20. I can take an x squared out of all 3 terms. I can take a y cubed out of all 3 terms. So again, we're going to take the first term and divide it by our GCF, leaving us with 3y squared. We'll take the second term, divide it by the GCF, and we are left with negative 2y cubed. And lastly, we'll take that third term, divide it by the GCF, to be left with 4x cubed. That is our final answer. The next type of factoring that we want to look at is difference of 2 squares. Before we do anything, we should always check for a GCF first. I can take a 2 out of both the 8x squared and the 18. That leaves me with 4x squared minus 9. Now, here's a little formula. This is going to help us set up our difference of 2 squares. First, let's figure out how we can identify. Difference insinuates that we are subtracting, so you should always see a subtraction sign when you are doing a difference of 2 squares type of factoring. Next, you need 2 numbers that you could take the square root of, so 2 perfect squares. I have 4x squared and I have 9. I know both of those square roots and they are being subtracted, so this is perfect for a difference of 2 squares problem. You always want to make sure you include your GCF in your final answer. When you see a difference of 2 squares, you want to open up 2 sets of parentheses. You look at the first term and you take the square root. Put it in the front of both parentheses. Then you want to look at the last term and take the square root. Those go in the back. One gets a plus, one gets a minus every time. That is our final answer. Let's look at another problem. Again, the first thing you always want to do is check for a GCF. I do see that I could pull a 3 out of both terms, leaving me with x squared in the front minus 9. Remember, you always want to keep your GCF in your final answer, so we'll bring that down automatically. I see a difference of 2 squares, subtraction and 2 perfect squares. Great, I know to open up 2 sets of parentheses. I'll look at the first term, take the square root, put it in the front. I'll look at the back term, take the square root, put it in the back. One gets a plus, one gets a minus. That is my final answer. Let's do another one. 16x to the 4th minus 81. First, I always look for a GCF. There happens not to be one in this problem. Moving on. I do notice a difference of 2 squares. I see subtraction and I see two perfect squares. So what does that tell me? To open up two sets of parentheses. Now I can look at the first term, take the square root, and put it in the front. Look at the back term, take the square root, put it in the back. One gets a plus, one gets a minus, every time. But wait, I'm not actually done. I see 4x squared plus 9, and I don't see anything wrong with that. That's a sum of two squares, which doesn't exist. That cannot be factored anymore. However, the second set, I have 4x squared minus 9. That's another difference of two squares. I'm not done with this problem. So I'm just going to go ahead and rewrite the next piece. There's nothing wrong with it. However, the second set of parentheses can be broken apart even further. Go ahead and take the square root of the front, put it in the front. Take the square root of the back, put it in the back. One gets a plus, one gets a minus. Now that is my final answer. Let's take a look at another type of factoring, trinomials where a is equal to 1. When I say a, I mean the coefficient in front of the x squared term in a quadratic in standard form. So in this example, I have x squared plus 7x plus 12. There's technically an imaginary 1 in front of the x squared. This is an a is 1 problem. Cool. Every time you have this type of question, you always open up two sets of parentheses and pop an x in the front every single time. Now our goal is to find two numbers that multiply to your c term and add to the b term. So I need numbers that multiply to 12 and add to 7. So let's look at 12. I know 1 times 12, 2 times 6, and 3 times 4 are all factors of 12. Which one of those options will give me 7? Well, 3 times 4 will. Positive 3 and positive 4 multiply to 12, but add to 7. This is your factored answer. Let's look at another problem. Again, a is 1. I can immediately open up two sets of parentheses. Pop an x in the front right away. I need two numbers that multiply to c and add to b. Let's list our factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which one of these is going to multiply to 24 but add to 10? 2 and 12 are going to be my answers. Now you may be thinking, wait a second, 4 and 6 can also give me 10. So let's look back at the problem. It's actually a negative 24 and a positive 10. I need two numbers that multiply to negative 24 and add to positive 10. I cannot do that with 4 and 6. However, I can do that with 2 and 12. It's just that the 2 needs to be negative and the 12 needs to be positive. This is my factored answer. The next type of factoring we're going to look at is grouping. This is when you have 4 terms. Anytime you have 4 terms, you're going to group the first 2 and then the last 2. You're going to take a GCF of the first 2 terms, then you're going to take a GCF of the last 2 terms. You'll combine your outsiders, you'll bring down one set of parentheses. Let's put that into action so it makes a little bit more sense. I'm going to take a GCF out of the first 2 terms. X squared. What's left? X minus 2. Now I'm going to take a GCF out of the last 2 terms. 4. What's left? X minus 2. Your parentheses will always match. You see how I have x minus 2 and x minus 2 in both sets of parentheses? That should always happen or you are factoring wrong. My next step is to combine my outsiders. So x squared plus 4, they're going to get combined. Now I'm just going to bring one set of those parentheses down. This is my final answer. Let's look at another example of grouping. Again, we're going to group the front and then we're going to group the back. I'm going to take a GCF of the first two terms, which is 2x squared. I'm left with 2x minus 3. Now I'm going to look at the last two terms. I'm going to take a GCF out of negative 5. I'm left with 2x minus 3. Again, my parentheses match, so I know I'm doing it right. I'm going to combine my outsiders. I'm going to bring down one set of parentheses. This is my final answer. Last type of factoring. This time, trinomials where a is not 1. Let's look at this example. Notice I have a 6 in front. This makes things a little bit more difficult. We should always check for a GCF first, and I do have one. Let's pull out a 3. Now, I would hope that that would take care of my A is not 1 problem, but it actually didn't. I still have an A that's not 1. How are we going to answer this type of question? Well, the first thing you have to do is take your A and your C term and multiply them. This is going to give us 6. I need numbers that multiply to 6 but add to 7. I've got 1 and 6, 2 and 3. 1 and 6 are going to be my working numbers here. I'm going to rewrite this trinomial by replacing 1 and 6 instead of 7x. So I have 2x squared plus 1x plus 6x plus 3. Notice if I combine my like terms, I would still get a 7x in the middle. I haven't changed the problem, I've just manipulated it to look a bit different. Now I have 4 terms. Well, didn't we just learn how to factor with 4 terms a moment ago? We're going to group. Group the front two, group the last two. Take a GCF of the front, take a GCF out in the back. Combine your outsiders, bring down one set of parentheses. Please do not forget your GCF needs to be part of your final answer. Now we are done. Let's do another example. The first thing you should always check for is a GCF. I don't have one here, so I'm going to move on. Because A is not 1, I have to do this the longer, more annoying way. So, the first thing I'll need to do is multiply A times C. This will give me negative 24. Now I need two numbers that multiply to negative 24, but add to 5. So let me go ahead and write my factors of 24. Which one of those choices is going to give me 5? 3 and 8. So I will replace that 5 with a negative 3 and a positive 8. Now I have 4 terms. At this point, I can now group. I'll take a GCF of the first two, and I'll take a GCF out of the second two. Combine my outsiders, bring down one set of parentheses. This is my final answer. All right, guys, that is the lesson for today. Be sure to subscribe for more math videos.